Okay, in this drawing here, lot of definition, so you gotta take some good notes today. In this drawing here, this line right here, this is the transversal. And the exact definition of a transversal is a line that intersects two other lines. Okay, that is the definition of a transversal. This, by the way, children, is a big introduction to geometry. And geometry is something you won't even get until you're a sophomore in high school or so, but it's a simple little thing that'll give you just a little taste of what geometry is. Okay? Got that? Got that written down? Okay, because here is a phrase that pays that you need to know. Write this down in quotation marks. Who's that keeps whispering while I'm talking? Is that you again? Josh? One more time, you'll be out there, and then I'll just give you the website that you can look at. You can do it on your own, probably tomorrow during lunch. Sit in the computer lab, you be able to watch this whole thing. It's better than cats. I've been nominated for an Oscar for this. Write this down word for word for me, please. In quotation marks. If two parallel lines are cut by a transversal. And then you can put, is there two L's in transversal? No. And then dot, because that is going to be the phrase that we are going to repeat numerous times today. Okay? Write that down. If two parallel lines are cut by a transversal. Now you need to number these things with me. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6, 7, 8. Get those numbered just like I have them there. Don't mix them up. Okay. Now we've got this. First thing we are going to talk about is corresponding angles. What is corresponding angles? Okay, you will see that there are two groups of 4 angles here, right? You got this big clump right here and this big clump right there. Corresponding angles are the angles that if you could take this clump, pick it straight off the paper, and put it over top of this clump, corresponding angles would be right on top of each other or on bottom to top. Okay, so angle 2, if I pick that up, put it down over top, would be right over top of what angle? Angle 6. So angle 6 and angle 2 are corresponding angles. Okay, so corresponding angles are angles that match up. Other corresponding angles would be angle 1 corresponds to what angle? Angle 1, if you picked it up, took it out, put it on top there, Holly, is?
5.
Angle 5. Angle 4 would correspond to angle 8, correct? Angle 3 would correspond to angle 7. Stop me there if you don't get that. You just take this clump, pick it straight off the paper, put it back down on that clump. They're the ones on top of each other. Now, here comes the phrase that pays. If two parallel lines are cut by a transversal, number 1, corresponding angles are, guess what they are? Angle 2 and angle 6 are equal. You can abbreviate just like I did there because you should be able to figure that out. Corresponding angles are equal. And you have to say it with this. If two parallel lines are cut by a transversal, that's the high school way to do it, then corresponding angles are equal. That would mean if angle 7 is, I don't know, 105 degrees, what other angle is 105 degrees, Gabe? Angle 3. Perfect. See, you've already got some of that. All right, moving ahead because we've got about a zillion of these things to do. Okay. Let's see what else they tell us here. Okay. Here we go. Next thing we're going to talk about is alternate interior angles. Alternate interior angles. Okay, listen carefully to this. Just a lot of stuff to know. When you've got this two parallel lines cut by a transversal, there are what's called interior angles and there's what's called exterior angles. Just like it sounds, children, interior angles would be found where? Taylor?
Inside.
Inside, and that's right here. Okay? This right here, the yellow part here, that is the interior. I probably won't use yellow because it's kind of a hard color to see. That is the interior angles. Well, guess what? Guess what this out here and this right here is called? If the inside ones are called the interior angles, then the ones that are not inside, Annalise, would be the
Exterior.
Thank you very much. So we've got interior angles and we've got exterior angles. So you got two groups of exterior angles and just really the set inside there. Now, so first of all, let me ask you, there's 4 interior angles. What are they? They're angle 3, 4, 5, and 6. Those are all interior angles. But I'm not just talking about interior angles, I'm talking about alternate interior angles. That one's a little tougher. Any idea what alternate means? Alex Bowler?
Alternate angles would be 5 and 3
You are correct, but why?
because they are on the opposite sides
Right.
of the transversal.
Alternate really means to flip-flop. You know, if you alternate between this thought and that thought, it means you're kind of going back and forth, whatever that is. So this, alternate interior angles, would be angle 5 and angle 3, because they're alternate sides of the transversal. There's one other set of alternate interior angles there, and that would be angle 6 and angle 4. Now, again, why do we put this in this section? Well, because it comes from this. If two parallel lines are cut by a transversal, then alternate interior angles are, guess what? Guess what the alternate interior angles are? 5 and 3 are, and 6 and 4 are equal. Okay? Angle number 5 equals angle number 3. Whatever the measurement of angle 5 is what 3 will be. Okay? Angle 6 will equal angle 4. Now notice these two don't equal each other. 5 and 6 aren't equal, but 5 equals angle 3 and 6 equals angle 4. Now you're starting to really get excited about this, I can tell. Ready? More talking. If we've got alternate interior angles, then guess what we also have? We also have alternate exterior angles. So, alternate exterior angles, just like we talked about there. I'm losing room here. Okay, here's the exterior angles. The exterior angles are angle 1, 2, 7, and 8. But I'm not talking about just those. I'm talking about the ones that are alternate. What are the alternate exterior angles? They are angle 8 and angle what? Angle 8 and angle 2. They're alternate sides of the transversal. They're exterior angles. So angle 8 and angle 2, as well as angle 7 and angle 1. And guess what we're going to say about those? Alternate exterior angles are equal. They are. Exactly. Alternate exterior angles are equal. So much to do and so little time to do it. Okay? And now we have just one, well, and again, anytime you say this, you have to preface it with that little phrase we said there. Because this doesn't work if they're not parallel lines. It only works when you have two parallel lines cut by a transversal. And then we've got what's called supplementary angles. Have we ever talked about those? Good, because I want to spend a lot of time on that. Supplementary angles. What are supplementary angles? This is a review. Supplementary angles are Kyle Westfall.
Two angles that equal 90 degrees.
Not 90 degrees, you're close. Those are complementary angles, yes. Two angles that make 180 degrees, which is a straight line. Okay? So, looking back at my thing here, how many supplementary angles do you see on our little transversals cut by parallel lines there? Give me one set of supplementary angles. Which angles are supplementary? Gabe says angle 1 and 2 because they form a straight line, absolutely. That's one of many. Taylor says
5 and 6.
5 and 6, that's 2 of many. Phil?
3 and 4.
3 and 4, we're getting all the ones that are horizontal there. Yes? Holly?
8 and 5.
8 and 5 are also, yes, that's where we're going. Colton?
4 and 1.
4 and 1. Lauren?
3 and 6.
Nope, 3 and 6 don't, they're not together. They have to form a straight line together. They have to be kind of together, connected, as it would be. Taylor?
2 and 3.
2 and 3. Those together form a straight line. Bill?
6 and 7.
6 and 7. Okay, enough of that. You got that. So here we go. Let's put this all together as best we can. Ready? So you got all those notes there because I want you to draw one more set of parallel lines cut by a transversal. I'm going to cut it this way just for fun. And it doesn't matter how we number it. Let's just go 1, 2, 3, 4, 5, 6, 7, 8. And here, this will give you the little feeling of what geometry is like. Because geometry is about being able to prove things based on things that are given and things that are statements of truth. Okay, for example, right there I say angle 8 equals 60 degrees. Angle 8 equals 60 degrees. Based on that one fact, you should be able to tell me what every angle on this thing is. You should be able to tell me 1, 2, 3, 4, 5, 6, and 7, how many degrees they are. Anybody want to take a shot at 1? And you have to give me the reason why. You can't just say, well, this is that. But you have to say why it is. Alex Vollmer?
Number 1 equals 120 degrees. Or angle. Yeah. No,
I'm going to say no, it doesn't. But I think you're on the right track. I just don't think you kind of got it there. You're starting to. I would suggest we kind of start maybe with. Well, I guess not. I won't tell you where to start. You want to give me another shot at 1? First of all, we just talked about 1 2 seconds ago.
Let's go 7.
Angle 7 is,
120 degrees.
and then you have to state the reason why.
Because they're supplementary.
Right. And then you would say because of supplementary angles. These two, these two have to form 180 degrees, so that has to be 120. That's a definite given there. Perfect. Boom. Let's go a little higher here, a little deeper, a little wider. For example, you should be able to tell me, I'm gonna give you the one. Angle 4 is how many degrees and why? Ava?
It's 60 degrees.
And why is that?
Because it is the same as.
But why? What's the word I'm looking for?
It's corresponding.
Very good. Because it's a corresponding angle, and we know corresponding angles are equal. That's what geometry is about. You have to be able to prove why you can say that. How about another one? We missed one, and I don't see it on here, but I don't think they told you. There's one more that they just don't say. Taylor Pavia, give me one.
Angle 3 is 120 degrees.
Angle 3 is 120 degrees, and there's two reasons you can give me. What two reasons is that? Number one, because of supplementary angles, because I knew that this was 60 degrees, but another reason why 3 is 120 degrees, Colton, is because it's,
Corresponds.
yes, and it's corresponding. What about angle 1, 2, 6? Anybody? How big is angle 1 and why? Emma Kunacek,
60 degrees.
why is angle 1 60 degrees? Yeah, well, angle 1 corresponds to 6, and I don't have a 6 down here yet. But you can give me another reason. It is supplementary. Anybody want to give me the other reason? There is another reason I can give besides being corresponding. You're missing one. I'll give you a clue. It's because angle 8. Angle 1 and angle 8 are, Caroline?
Alternate exterior angles.
Correct. And the saying goes, if two parallel lines are cut by a transversal, then alternate exterior angles are equal. So this has to be 60 degrees as well. How about angle 2? How many degrees is angle 2? Josh?
120.
Why?
Because it's supplementary.
Supplementary. Good ice. Is there another reason why?
Because it's the alternate exterior angle.
Right, because it's the alternate exterior angle of angle number 7, we know that those are equal. So we're just missing angle what? 5 and 6. Angle 5 and angle 6. Let's do angle 6 at 60 degrees. Why? Ava?
It's an alternate interior.
Alternate interior angles are equal. And the last one, angle 5 is how many degrees, Howard?
120.
Because it's, you could give about 3 different reasons for that one.
So
It's supplementary to angle 8, it's supplementary to angle 6, it corresponds to angle 2, it's an alternate interior angle to 3. Okay, and that's a little bit, ladies and gentlemen, just a little bit about like what high school geometry, just a little bit.